I'll let people trickle in, and we're going to start in a second.
The whole thing.
All right, guys, we are recording. Hopefully, most of us are back. That's what it looks like. Again, remember I told you some of the problems we will do here will resemble the problems we did in chapter one. This is an example. There are a few more like that, which is not a bad thing. I wouldn't say it's identical, but it builds on what we learned in chapter one. Ryan is building matchstick sequences as shown. Okay. How many matchsticks will he use for the nth figure? Hmm. Now, when you see this, guys, sometimes they'll ask for the number of squares, sometimes they'll ask for the number of sticks. Here, they're asking for the number of sticks. Read it carefully. Sometimes people read squares and they give me the wrong answers. So I'm going to put the first term is like this, the second term, and the third term. Now, look at the picture, guys. Every shape has an elbow, so to speak. This is the elbow. Okay. The elbow square in each shape will require four matchsticks. Doesn't matter how large the figure is. Is it the 100th shape, 99th shape? Doesn't matter. The corner, I'm going to call it elbow, will require four sticks. So let's write it down. Okay. Let's write it down. That's an important fact or important observation. Each term will have an elbow. I'm going to call it elbow square. And that square will need four matchsticks. Okay, remaining squares. Okay, I'm going to call it the vertical leg. These are, I'm going to call it the vertical legs. Okay, now take a look. The squares in the vertical legs will require three, and the squares in the horizontal leg, for the first one, there is only one. For the second one, there are only two. For the third one, there are three. So this is two, your horizontal leg will have two. If this is three, your horizontal leg will have three. If this is one, your horizontal leg will have one. Okay, that's consistent. Let's compare one to the vertical one. If you have one, you have two vertical. If you have two here, you have three vertical. If you have three here, you have four vertical. So let's write down another fact. The vertical leg, the vertical leg will have n plus 1 squares. The vertical leg will have n plus 1 squares as observed. Why are we talking about n? Because they want us to find the answer for nth figure. That's why. All right, so let's put this guy here, put a period. And the horizontal leg for the nth one will have n plus, sorry, just n squared. Okay, very important, guys. Okay, look at the picture. There's no other way you can do it. You have to look at the picture, and based on the picture, you have to decide. You can't memorize it. I can change the shape. I can make the horizontal leg longer by 1 or 2 units. So be careful. Now, we have established earlier that all the squares in the vertical legs and all the squares in the horizontal legs will only take three matchsticks per square. So what's my answer? Okay, for the nth term, it will be 4. Where's the 4? It's for the elbow. You will need, or Ryan will need, 4 matchsticks to build the elbow. For the nth term, he will have n plus 1 vertical squares, but each of them will need 3. And for the horizontal leg, Ryan will build n squares. For each of those n squares on the horizontal leg, he will need 3 matchsticks. This is my answer. I have to simplify it just a little bit. There's not a whole lot you can do. For distribute, you get 3n plus 3 plus 3n. And I'm going to put it in one line. It'll look a little better. And 3n plus 3n is 6n. 3 plus 4 is 7. 6n plus 7. I'm going to check my work, okay? Okay, once again, 4 matchsticks for the elbow, okay? 3 times n plus 1 matchsticks for the vertical leg, and 3n matchsticks for the horizontal leg. Of course, I'm pointing toward the third figure, but you're thinking about the nth figure. All right, now 4 is 4. 3n plus 3 is the distribution of 3 over n plus 1. 3n. 3n plus 3n is 6n. 3 plus 4 is 7. That sounds about right, guys. I'm going to pause here. Good 1 minute. Yeah, good 1 minute. To see if you have any questions for me. All right, guys. Let's see what's next. Eight. All right, another tricky one. Okay. So let's read it carefully. Write an algebraic equation relating the variables described in each of the following. The pay P for T hours if you're paid $8 an hour. Well, this is not that bad. You're going to say your pay must be 8 times T. Why? Each hour you make $8. In T hours, you're going to make $8 dollars. Done. Now the next one is really a little well, I'm going to leave it here. So what's going on with the next one, guys? Read it very carefully. The pay is P, and for T hours, you're paid $15 for the first hour and $10 for each additional hour. Okay. So no matter what, I'm assuming T is bigger than 1. So for the first hour, you're going to make 15 bucks. If you are working for T hours, guys, you have accounted for the first hour. You have to account for T minus 1 hours, but you only make $10 for the subsequent hours. So it'll be 10 times T minus 1. This is a dollar amount. Once again, $15 for the first hour. That's what you're going to make. Then you have, since you work for T hours, you have to work for T minus 1 hours at the rate of $10 per hour. And I'll do a little calculation, a simplification. And I'll pause here just a little bit. All right, let's see. What else is going on? I don't think this one is a bad one. Okay. For a particular event, a student pays $5 per ticket and a non-student pays $13 per ticket. If X students and 100 non-students buy tickets, find the total revenue. Revenue means how much money they make, how much money they get. For X students, from X students, they have received 5 times X dollars. Because each student pays $5, and students will pay 5X bucks. 100 people, the non-students, will pay 13 times 100. What a good idea. 100 bucks. And that's going to be 5X plus 1,300. So that's number 9, which wasn't that difficult. I'm going to give you 1 minute here. Now, guys, here is what I was thinking. We have a few more problems from this section. They're a little messier, and I don't want to do it today. I'll do it next week. That's the plan. So, no more lecture today. I'll be happy to be around to take any kind of questions. Something from MATLAB, something from yesterday's lesson, something from the past that we did when we were meeting face to face. And just to touch base, my understanding is next whole week till Wednesday, we meet online. And which won't affect you guys. We are being asked to go to campus on Thursday next week. So maybe we'll have at least 2 more online sessions. So I don't have anything else to share. I am recording. If you want to leave, feel free to leave. I'm going to leave when the last person leaves. Thank you very much for coming. Hang around if you have questions for me. Rachel, do you have any questions for me? Any questions for me, Rachel? Okay, no problem. I'll see you next class. Bye-bye.